Okay guys, it's Mrs. Carball. I'm going to go over the heat equation with you and solve some problems and do some dimensional analysis to help you. Okay, so let's look at the problem that says this. How much heat does it take to raise the temperature of 100 grams of gold by 25 degrees Celsius? Okay, so now we have our formula up here. E, heat energy, which is in joules, mass in kilograms, CP, which is your specific heat, constant pressure, which is in the units joules per kilogram Celsius, and then in parentheses, the change in temperature. Temperature 2 minus temperature 1, and that is going to be in Celsius. Okay, so let's look at what is given here. All right, so we're looking, first let's look at what are we looking for? How much heat does it take? So we're looking for the E for this one, okay? So we are looking for E. All right, and that's going to be in joules. Okay, now we're going to look at what is given. Okay, we have our mass equals 100 grams. Our temperature change, remember Ms. Carball told you that the triangle T means change in temperature. This means difference, okay? So they already gave you what the temperature difference is, and that's 25 degrees Celsius. And then they say gold. So we're going to look for the specific heat of gold. And here it says 129. So the specific heat CP equals 129 joules over kilograms Celsius. Okay, so we're going to get started on this. All right, first, we can't leave it at 100 grams. We have to put it into kilograms. So let's do some dimensional analysis. We have 100 grams times, and we're going to put the grams on the bottom because we have to cancel it out. And how many grams equals 1 kilogram? 1,000. Okay. So now we're looking at this. We're going to cross off our grams and we're going to multiply across. 100 times 1 gives you 100. And then you have 1,000 on the bottom. And we only have the unit kilograms. So if you divide 100, let's put on my handy dandy calculator, 100 divided by 1,000, you get 0.1. So we have our mass equals 0.1 kilograms. So do we have everything in the acceptable values in order to put it in our formula? Well, we have kilograms for mass, good. We have our change in temperature in Celsius, good. And then we have our specific heat at 129 joules per kilogram Celsius. Okay, so now we're going to find out how to do this. So we got to find E, and E is going to be in joules. All right, so we got our mass, which is 1 kilogram, times CP, and our CP we said was 129 joules kilogram Celsius, times our change in temperature, which was 25 degrees Celsius. Okay, so now we're going to multiply this all the way across. All right, so when we multiply all of this across, we have our kilograms here, kilograms there. Can we cross those off? Yes, we can. Kilograms, kilograms. We have our Celsius and Celsius there, correct? Let's cross those off. So now we're only going to have joules there. So if we only have joules there, that's what we need for our E. So let's multiply 0.1, clear? 0.1 times 129 times 25, and we get 322.5. What do we have left? We have joules. So E equals 322.5 joules. Good to go. All right. Next one we have is, let's talk about our coffee maker. All right. Our coffee maker, this one reads, a coffee maker heats 200 grams of water from 15 degrees Celsius to 100 degrees Celsius. How much thermal energy was required? Very similar to the last one. We have to change the 200 grams into kilograms. So we are looking for, again, E. Okay, I'm going to do a squiggly line here. E, and we have to have that in joules. That's what we're looking for. What are we given? We are given the change in temperature we have to figure out, which is 100 degrees Celsius minus 15 degrees Celsius. And when we calculate 100 minus 15, we get 85 degrees Celsius. Okay, that's good. Then we have water. And water, when we look up water, it's 4,184 joules per kilogram Celsius. Okay, so we are given our CP, which equals 4,184 joules per kg Celsius. Okay, then we are given 200 grams. Well, 200 grams we have to change into kilograms. So we're going to change this into kilograms. So we go 200 grams times, grams down here, 1 kilogram, 1,000 grams equals 200. So we're going to divide. You're going to go 200 times the 1. We're going to have it in kilograms. And then we have the 1,000 on the bottom. When you divide that, you have 0.2 kilograms. Okay, so now we have our mass, which equals 0.2. We have our CP, 4,184 joules per kilogram Celsius. We have our change in temperature, which is 85 degrees. So now we just got to plug in our numbers. So now we have mass, 0.2 kilograms, times our CP, which is 4,184 joules over kilograms Celsius, times our change in temperature, which is 85 degrees Celsius. Okay, so let's start crossing off the ones that we already have. So we'll just wind up with our joules now. Okay, so now we're going to take our 0.2, multiply it by, so Ms. Carval's going to do that, 0.2 times 4,184 times 85, and we get, did I do it right? 0.2, oh, yep, we have 71128 joules. And that is our answer. Okay? I hope this helps.